Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from Isilon. We have Nick Kirsch. He's the Director of Product Management at Isilon. And Nick, welcome to the show today.
Thanks, Rich. Happy to be here.
Well, I'm glad. We were just talking about the weather. It's cloudy in Portland, and it sounds like it's cloudy in Seattle. But let's make the best of it here. I've got your slides up. Do you want to start with that?
Sure, I'd love to. Try to add a little sunshine to this day. So I'm going to talk about big data and big opportunity, really how to maximize information value for the HPC community. And let me start first by talking about who is Isilon. Isilon is really the foundation for EMC's big data storage strategy. We are the pioneer and hold the leadership category for scale-out NAS, something that we began innovating on in the year 2000. Over the course of the last 10 years, have really developed an enterprise-class, extremely differentiated product. We scale today to 15 petabytes of capacity in a single file system, single volume, over 1.6 million IOs and 85 gigabytes per second. So those are all big numbers, which really shows you how big and how fast Isilon can get. But what's really differentiated, and the most important thing about Isilon, is that it's extremely simple to scale and operate. And that's been the differentiation that has been important for our customers, both in the commercial HPC space as well as the enterprise. Big data. Everybody's talking about big data. You might have heard it in mainstream press. You certainly saw it at Supercomputing if you were here in Seattle. The big question you're probably asking is, so what? What does it mean to me? What does it mean to my organization? I think the first thing to think about is big data and this revelation that big data is a challenge, is an opportunity. It's really helping drive IT transformation. I have before you a chart that shows IDC, file-based versus block-based data growth. And at first you'd say, well, how does that relate to big data? And it's important to think that the technology behind big data is largely file-based workflows. It's applications that independent software vendors are creating or internal R&D departments are creating that's generating a large amount of rich content and technical content that's all being housed in files. Files are this very easy to use and share mechanism, easy to organize, et cetera, for the application, so they don't have to necessarily depend on built-in infrastructure. So as you can see in this chart, file-based data growth has not only taken over block-based data growth, but is just continuing to accelerate at an extremely rapid rate. And so at Isilon, we really associate big data with file-based data growth, and that's where our platform has been designed, is to help simplify and give organizations leverage over file-based data and big data. Let me introduce you to a concept that I like to call the big data virtuous cycle. A lot of people look at big data or file-based data growth or growth in general. That's a challenge. How do I deal with this massive amount of information that's coming my way? I've got increased concurrency of my users. I've got more sophisticated applications with additional needs to coordinate and communicate. Boy, that seems overwhelming. But I think something that we've come to recognize, and that recognition has been driven by our customer base, is that big data really is an opportunity to create value. I like to think of this as the natural resource for the information age. So if you start with the fact that there's an amazing amount of data that can be collected and aggregated from a variety of different sources, different sensors, different log files, etc. You can aggregate and collect this information. If you can then store that data in a scalable infrastructure, you're now in a position to leverage data and turn it into information. And once you have information, you're now close to value. And that's what we call the value creation or the virtuous cycle of big data. And a few examples that I love talk about. One is an example of an Isilon customer is a telecommunications company. And just as being virtue of a telecommunications company, they create logs and they track information about all their routing out there on the network, whether it's international or domestic, all their peering points, et cetera. So they're constantly collecting this data. And for years they've been collecting this data because that's what good telecommunications companies do. But more recently, they've realized that if they take that data and they analyze it, they can find patterns that are associated with various network security events. So suddenly, this meaningless log data that they were collecting is now useful to go and see a Trojan attack or a virus infestation that's occurring. So they were able to take that, turn it around, and make it an internal service for their own network security, and then flip it to an external service to their customers. And now their enterprise customers have preemptive warning about these network security events. And that's one example of taking what could have been just unutilized data and turning it into information by having this scalable storage and compute infrastructure. I think it's a perfect example for big data. Let me talk about a few other examples of big data and commercial HPC. A lot of these really are areas that Isilon has a strong presence in. Media entertainment, if you've seen the transformation of the media entertainment industry from analog to digital, this is another fantastic example for big data, the massive digitization of processes and tools and technologies. But it's all opportunity. It gives the media industry a way to create better pictures and audio, things they've never been able to do before, to introduce 3D technologies. This is a fantastic example of leveraging that digital technology and bringing value out of big data. Energy sector, I mentioned the word sensor earlier. Energy companies are deploying more and more sensors than they ever have before, creating seismic events, getting more and more data about what lies beneath the ocean or lies beneath the landmass, and they're able to analyze that and find new natural resources that we build our natural economies on top of. That's all examples of big data. Without the power to harness that data and turn it into value, they're just spending money on sensors that accumulate things they can't use. Life sciences is another example where Isilon has been particularly strong, but it's enabling organizations, research organizations, commercial organizations to sequence genes and to go and look for patterns that allow us to have personalized medicine. So now I walk into the doctor and he thinks my symptoms look pretty normal, but maybe they're not exactly there. He can go and prescribe a medicine just for me based on my genetic makeup. That's pretty compelling. That's something we've never been able to do. Simply now that we have the technology to enable the scale, to allow us to analyze, we're in a position that life can be better. And there's many other examples of this, whether it's the digitization of other industries like medical imaging, like financial services, whether it's the continued advancement in resolution, things, for example, in semiconductor design where they're working at such a tiny scale. It's amazing the number of electrons that are flowing across these wires. I mean, they're getting that count so small. Computational modeling, when you think of the car design or the ship design, the efficiencies they're building in, all of these things really are fantastic examples of big data at work and big data driving value for businesses and for consumers. Now, one thing that Isilon has clearly seen and participated in is that as the IT transformation is occurring, as big data is penetrating both commercial HPC and enterprise customers, they found that their traditional storage environments simply are not ideal. They're not scalable enough, they're not efficient enough, they're just too time-consuming and complex. And the example here is scale-up storage, and I think the easiest example I like to think of is you're in a world that's really very, very physical and aligned. So you build a compute infrastructure, you build a network infrastructure, and it goes to a storage platform, and that's for one application. And you can set that thing up, and you can make it just right for that one application. That was the world 10 years ago and 15 years ago. But now that you're in a big data environment, you need to build that application such that it scales. You're not going to have one small set of storage environments. You're not going to have one set of compute environments. That's going to continue to scale as there's more data available to analyze, as there's more processes to go and execute concurrently. You need that environment to continue to scale. It gives you a time to market advantage. It gives you a research advantage. It gives you a advantage over your competitors. So as we turn and think about what is the solution, it's really been the scale-out storage technologies. Isilon is one example of scale-out. There are certainly other examples of scale-out, both in the open source community and in other enterprise storage vendors. But the key thing here is that this is technology that is designed to harness industry-standard hardware, use intelligence in software to build a scalable infrastructure. Best example for that probably is the server virtualization and cluster computing environments. 10, 15 years ago, all we did was build bigger and bigger compute servers to house our applications. Now, anywhere you go, whether it's HPC or whether it's enterprise computing, you will see large server farms. Those server farms will be used for highly distributed applications, or they'll be used for virtualized environments with many different applications contained within that. But that's an example of scale that can simply allow these organizations to get more value. Same is true for the storage architecture. So scale-out storage enables the leveraging of that industry-standard hardware into an infrastructure that can be scaled from a capacity perspective or from a performance perspective while maintaining the simplicity of management and giving you the efficiencies of cost. It really has made the difference for some organizations where they simply wouldn't exist if they couldn't get the scale that a scale-out storage infrastructure provides them. I think it's really important to think that it really is day and night different at scale. And there's a lot of real-world problems as you think about developing telescopes, from a consumer to an at-scale problem. If you think about developing airplanes, from a remote-controlled airplane to an actual passenger or commercial airplane, when you change the scale, the technology needed to implement that changes dramatically. So as we compare scale out versus scale up, it is night and day different. In a scale up world, it's small. You're able to tightly couple typically proprietary hardware together and align it. But in a scale-out world, you've got to design the system for somewhat arbitrary scale. You can't share anything. You can't depend on a tight coupling. In a scale-up world, there's not a lot of knobs and levers to twist. You're able to succeed in a manual environment. Now, over time, too many of those means that you've got, in aggregate, many things to worry about managing, and it's very complex. So you've got to automate that system. In a scale-out environment, you've got transparent data movement versus manual data movement because now there's too much data to worry about classifying and moving in a manual fashion. We think of a scale-up environment, the example I just gave about being able to tightly couple an application to the compute and storage infrastructure, that's fine when it's at a small scale. But when you're at a large scale and you have thousands of applications and you have developers and engineers putting applications into these environments at their own will, think of an Amazon EC2 environment where you've got a massive shared compute resources and you have no control over the computation that's occurring there. You need to know that the storage system can scale effectively without all of this manual tweaking. So rather than having bottlenecks associated with this strict alignment, you need linear scalability. As the storage system gets larger, as the amount of concurrency increases, the performance is predictable and linearly better. And then finally, if you think about operating these environments, again, when something is small, it's fairly easy to spend time managing that because there isn't a lot to do. But as that system gets larger and larger, that same management strategy changes in the sense that you've got to be able to manage a large-scale system as easily as you would a small-scale system, which means you build it differently, you design it differently. So we really think that it's night and different at scale, day and night different at scale. I think our customers find that, and certainly you'll see that in a lot of examples in the industry. So let me talk a little bit about scale-out NAS specifically. Isilon has been a leader in the space, as I mentioned earlier. 10 years, first to market with a scale-out NAS solution. Over 2,000 customers today, both in commercial HPC as well as the enterprise. And there's a few key value points that our customers and prospects that we talk to really find critical. The first is that it's simple to scale. I keep talking about the difference of scale, and maintaining the simplicity is critical for these organizations to be able to expand the amount of information or the performance that they get. So Isilon provides a single volume, single file system. It allows you to grow easily from terabytes to petabytes, and you really don't think about it differently. You don't have to worry about the fact that you just added 100 terabytes into the system. The user's access points don't change. The management structure doesn't change. And that's compellingly different when you look at a lot of the storage systems that exist today. Most of the time, the users and the applications, they're aware as the scale changes. They have to adapt to that. And that's one of the critical design principles that we have at Isilon. Predictable performance. Now, I talked about the need for linear scalability as the system grows larger so that you can predict what's occurring as you increase your capacity. I think it's also important to think about a pay-as-you-grow architecture. You don't want to have to over-invest. You don't know exactly the scale of the compute environment that you'll require. In some cases, information flow may increase. As that value of that information increases, you're willing to put in that investment, but you don't necessarily want to put it in up front. So a pay-as-you-grow model is very important, coupled with a predictable performance. It needs to be shared. It needs to be symmetric in the sense that you're getting all the compute and the capacity resources that you can out of the storage environment. Efficient to operate. Talked a lot about the efficiency in terms of using all of the compute and storage horsepower, but then also making sure that technologies like tiering, being able to identify data that's not being used, move it to low-cost media without you having to manually intervene. That's critical for these customers as they look at storing 10, 20 petabytes of information. Clearly needs to be available all the time. That's important for big data as it is important for enterprise IT. And the last point I want to make is that big data is not just for the fringe anymore. Perhaps 10 years ago, you needed to go to a national lab to really see petabytes of information. But now, every major enterprise vendor has petabytes of information. A lot of the commercial HPC vendors that we talk to, customers that we talk to, have petabytes of information or have millions of IOs that they need to deliver to their applications. So it's in the enterprise today, and thus they need the reliability characteristics. They need the data protection characteristics because this is a system that's critical to their business. So real quickly, not to belabor the point, you can jump on our website and look at all details around product more closely. But we have a few different systems that we provide to our customers, really in 3 different categories. And there's a lot of different options here, and flash options and networking options and memory options, etc. But the key is that you've got an S-Series, which is designed specifically for high transactional random access workflows. You've got a mid-range series which leverages SATA technology to give you high concurrent throughput. And then you've got an archive platform, the NL series, which is all about going cheaper and deeper, massive scale. All of these nodes not only form their own clusters, if you'd like, but you can put them together into a single file system. Also, something that's very different about Isilon is that the system can morph and evolve over time. So you might start out with a mid-range platform. As the application access patterns change, you find yourself adding some of the S-Series platform to get more transactional characteristics. But then you notice that there's a long tail of information, and so you add archive nodes into that platform. You do all of this from a single system, single management point. The applications don't change. The administration of the platform doesn't change. That's amazingly compelling in this space. So with that, thank you for taking the time. Hopefully you see the opportunity in big data. It can be a challenge without the right infrastructure, but with the right infrastructure, it's an opportunity.
Well, thanks for that, Nick. I think we certainly heard a lot about big data with SC11. The thrust of the conference was data-intensive computing. So what were you hearing from customers at the show?
That's a great question. So, when I was at Supercomputing 2011 here in Seattle, we had a lot of great customers come talk to us. Customers, obviously, in the commercial HPC sector, some customers in the academic and sort of government research sector. And I think data growth, as you would expect, increasing performance. Some of the trends that we saw were interest in the Hadoop infrastructure. So being able to leverage Hadoop in unstructured analysis environments. Scale, I think scale in general was a question that I'm sort of used to hearing, but it's kind of fun to see more and more customers talking about petabyte scale, whereas perhaps last year it was more hundreds of terabyte scale.
Sure. So, one thing I did hear about you guys, Nick, was that you guys are actually hiring in downtown Seattle, something like 200 people. Is that true?
That's definitely true, Rich. We're hiring quite a few engineers. Primarily, most of the hiring is in research and development. Isilon is growing very fast. A huge benefit of the EMC acquisition is that we are being enabled to grow as fast as we can. So if you think about from a customer access point, a lot of opportunities for Isilon. From a research and development standpoint, there are assets within EMC and other products in the portfolio that we can leverage, but we've also been given the opportunity to go and pursue some of the more advanced development that we've wanted to do but couldn't necessarily fund as a standalone company. So 200 engineers in Seattle, I believe in the next 12 to 18 months, and the better that Isilon does in the marketplace, the faster we'll hire. So that 200 is just the starting point.
That's great. So Nick, I saw, I got just bombarded with press releases prior to SC11, and the one from EMC talked about they were actually doing something with Lustre. Do you know anything about that?
I do, Rich. So EMC announced a high bandwidth VNX option. So outside of the Isilon product family, EMC also has a very high performance mid-range platform in VNX. And so they announced using the VNX SAN capabilities and the Lustre file system, they were able to set a bandwidth record through Lustre. So I think the EMC team at large has recognized that I like to think of the HPC market really as a triangle. You have the mid-range, what I call the commercial HPC sector. That's where Isilon is very strong. As you start to move down into the wider part of the triangle, you can think of that as more enterprise customers, perhaps doing HPC-like operations, but they might not call themselves HPC. But at the top of the triangle is really the most cutting-edge, high-performance requirements. And so it's not always about perhaps enterprise capabilities in terms of data protection. It's not necessarily about simplification of the environment. A lot of times it's about giving me the most performance that I can for the cheapest dollar. And that's a place where the Lustre file system shines. You see that a lot of high-end research institutions inside of the government space or inside the academic space. And that's because they essentially have a supercomputing environment and they're using Lustre as an extension of that main core memory. And we saw an opportunity with the VNX platform to couple it with Lustre and to move into the market for that high bandwidth sector of HPC.
Well, that's great. Good news. Always nice to hear about new players coming into the Lustre ecosystem, especially that enterprise play. That's really interesting. So, kind of a wrap-up question here, Nick. You're growing, you're hiring people, and everyone's talking about big data. Are you bullish on the future for Isilon and for this industry?
Rich, I don't know if I could be any more bullish. I've been at Isilon for over 9 years now. We've gone through some very exciting times as a small company, as a public company, and now as a part of EMC. The access to funding and customer environments and technology has never been greater. So as part of Isilon, I don't know if I couldn't be any more bullish. I'm very excited to be here. I think as far as the industry goes, the same applies. At Isilon, I've watched sort of the transformation of industries. Media entertainment, which is one of our core markets, we saw move from analog to digital. And then we've just seen that process be applied to industry, and that's really just the start of it. First, you digitize and you keep using the same processes that you had in the analog world, in the digital world, and then you start optimizing. So we're just at the beginning, really, as more and more sectors and enterprises digitize of that true digital revolution.
Well, terrific. Well, Nick Kirsch, I want to thank you once again for coming on the show today.
Hey, my pleasure, Rich. Happy to be here.
All right, man. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.